Imagine waking up one morning to find out that the single biggest tech investment in human history, over $1 trillion pouring into massive AI data centers right now, could become completely worthless. Not in 50 years, not in 20, possibly within this decade. That's not a nightmare scenario ripped from a sci-fi movie. That's the very real conversation happening right now, inside the most powerful tech companies on the planet, and the thing driving this disruption isn't another AI model. It isn't a new chip. It isn't even a software breakthrough. It's quantum computing, a technology so fundamentally different from everything we've ever built that scientists are struggling to find the right words to describe it. And right now, in 2026, quantum computing is starting to do something nobody fully expected this soon. It's beginning to kill the AI data center industry as we know it. To understand why this is such a massive deal, you first need to grasp just how insane the AI data center boom has become. We're not talking about a few server rooms getting upgraded. We're talking about one of the most expensive infrastructure buildouts in the history of civilization. In 2022 alone, the world spent an estimated $580 billion on AI-focused data center infrastructure. That number is almost impossible to wrap your head around. Microsoft committed over $80 billion in capital expenditures for fiscal year 2026 alone. Meta is projected to spend between $80 and $100 billion in 2026, up from $70 billion the year before. Google, Amazon, and every major hyperscaler on Earth is racing to build the biggest, most powerful AI computing facilities money can buy. And if you think that money is staying inside the tech industry, think again. U.S. utilities alone are planning $1.4 trillion in spending just to supply power to these data centers. Electricity prices for ordinary American families have already climbed nearly 40% since 2021, largely because of this demand, and some estimates say consumers could end up shouldering $700 billion of that $1.4 trillion through rate hikes. If you've been sitting at home wondering why your electricity bill keeps climbing, now you know why. If that doesn't shock you, hit like and subscribe right now, because what's coming next the AI data center energy problem isn't just an economic issue anymore, it's turning into a full-blown crisis. The International Energy Agency now projects global data center electricity consumption will pass 1,000 terawatt-hours by the end of 2026. To put that in perspective, that's roughly the equivalent of Japan's entire annual electricity usage consumed by data centers alone. The World Economic Forum projects data center energy use will double between 2024 and 2027. Some estimates suggest AI-driven data centers now consume more electricity than entire nations. In Ireland, data centers already account for 21% of the country's total electricity consumption, and that's forecast to hit 32% by 2026. In the U.S., Bloom Energy estimates total data center energy demand will nearly double, from 80 gigawatts in 2025 to 150 gigawatts by 2028. And here's the part nobody's talking about loudly enough. This explosive demand is slamming into a power grid that simply cannot keep up. Projects that secured land and financing years ago are sitting completely stalled, waiting on grid interconnection queues stretching 3 to 7 years in major utility territories. Data center cancellations tied to local community actually quadrupled in 2025, with at least 25 major projects scrapped outright. Maine became the first U.S. state to pass a full moratorium on large data center construction. The AI industry built itself a monster, and now that monster is eating the power grid alive. So, what does any of this have to do with quantum computing? Everything. Here's the fundamental problem with how AI works. Today, every single AI model you use, every ChatGPT conversation, every image generated, every video rendered by artificial intelligence runs on classical computing power. Classical computers, even the most advanced ones, work by processing bits, and every bit is either a 0 or a 1. Simple, reliable, but brutally energy-hungry at the scale modern AI demands. Training a single large AI model can consume as much electricity as 5 average American homes use across their entire lifetimes. Running that model afterward, what engineers call inference, happens billions of times a day across the internet, burning staggering amounts of power continuously, 24 hours a day, every day of the year. The entire AI data center Empire exists because classical computing has been the only tool we've had for this job. But quantum computing doesn't play by the same rules, and that changes everything. Quantum computers don't use bits, they use qubits, and a qubit can exist as a 0, a 1, or both at once, a phenomenon called superposition. On top of that, qubits can be entangled with each other, meaning the state of one can instantly influence another regardless of distance. Together, these two properties let quantum computers explore an almost incomprehensible number of possibilities simultaneously. Instead of stepping through them one at a time, the way classical computers do, the practical implication is mind-bending. A UBS analyst report published in early 2026 described the industry closing in on a quantum computer that could solve a problem in about 200 seconds, a problem that would take a conventional supercomputer 10,000 years. Read that again. 200 seconds versus 10,000 years. That's not a small improvement or an upgrade. That's an entirely different category of machine. And if that blew your mind, go ahead and hit like and subscribe, because the implications of that one data point are about to reshape every AI investment on the planet. Here's where the quantum story and the AI data center story collide in a way that should worry anyone who's bet billions on traditional computing infrastructure. In 2026, the three biggest names in quantum computing, Google, IBM, and Microsoft, have each crossed into territory considered purely theoretical just 2 years ago. Google announced its Quantum Echoes algorithm breakthrough, demonstrating the first verifiable quantum advantage with its Willow chip running a specific algorithm, 13,000 times faster than classical supercomputers. IBM has unveiled quantum processors pushing past 1,000 qubits. Microsoft has made serious progress with its topological qubit architecture, which promises natural resistance to errors without the complex correction systems that have slowed quantum progress for years. Microsoft's Majorana 1 chip, built on a new class of material called a topoconductor, is what experts are calling a genuine leap toward practical quantum computing. These aren't press releases, they're engineering milestones. The race isn't theoretical anymore. It's happening right now in real labs with real hardware producing real results. The specific threat quantum computing poses to AI data centers comes down to efficiency, and it can't be overstated. Right now, most of what AI data centers actually do is optimization, finding the best answer among billions of possible options. Training a neural network is an optimization problem. Recommendation engines, fraud detection, drug discovery, simulations, logistics, calculations, all optimization. And optimization happens to be exactly the category of problem where quantum computing shows its most dramatic advantages. Quantum annealing systems and hybrid quantum classical architectures are already starting to handle optimization tasks that would take classical supercomputers days or weeks, solving them in minutes or hours instead. Once quantum computers can routinely handle these workloads at scale, the need for hundreds of thousands of classical GPU servers, the machines that fill today's AI data centers, drops dramatically. Not to zero, but dramatically. The energy equation flips, the infrastructure equation flips, and that trillion-dollar investment sitting inside massive classical computing facilities starts to look very different. It's also critical to understand this doesn't require quantum computers to fully replace classical computing overnight. The disruption starts long before that, the moment a credible timeline for practical quantum advantage becomes clear. Many experts now believe that timeline lands somewhere between 2028 and 2034. Fault-tolerant, commercially viable quantum systems. At that point, the economics of continuing to build classical AI data centers start to break down. Why would a company spend $5 billion on a new classical GPU data center in 2026? If credible quantum hardware is commercially available by 2029 or 2030, the investment calculus shifts, capital flows shift, and companies that have already sunk billions into classical infrastructure face an increasingly uncomfortable question about the long-term value of those assets. Google's Sundar Pichai has publicly said he's optimistic that practical quantum workloads will emerge within 5 years. That's not a vague, futuristic soundbite. That's a CEO telling the market to start preparing. The energy dimension of this story can't be left out because it may be the single biggest driver of quantum computing's rise. Classical AI data centers don't just use electricity, they devour it. And the quantum alternative is radically more efficient per unit of useful computation. Quantum processors themselves use relatively little energy during actual computation. The energy-intensive part of quantum systems is the cryogenic cooling needed to keep qubits near absolute zero, colder. But here's the key difference. One quantum processor running millions of calculations simultaneously uses a fraction of the energy that hundreds of thousands of classical processors would need to attempt the same calculation sequentially. A 2025 analysis from Medium's Codex publication put it well. The most realistic promise of quantum computing isn't eliminating data centers entirely, but dramatically shrinking the energy and physical footprint per unit of AI work performed. That's a revolution in efficiency, not just a new piece of hardware. And in a world where AI energy demand is projected to equal Japan's entire national electricity consumption this year alone, that efficiency revolution isn't a nice-to-have, it's an existential necessity. If that scale of impact isn't worth your subscription, nothing is. So go ahead and hit like and subscribe. The geopolitical side of this story is just as staggering and just as undercovered. McKinsey's 2025 Quantum Outlook tracked over $36 billion in public and private investment flowing into quantum technology. S&P Global reports global investment in quantum tech had already topped $55 billion in 2025 alone. Governments across the US, China, Europe, South Korea, and Japan are treating quantum computing as a matter of national security, not just industrial competitiveness. The race to achieve quantum supremacy isn't just about who sells the better computer. It's about who controls the next generation of encryption, military logistics optimization, pharmaceutical discovery, financial modeling, and AI infrastructure itself. Whichever country or company achieves fault-tolerant quantum computing first will hold an advantage over classical computing rivals, comparable to a modern fighter jet's advantage over a World War I biplane. And nations that have built their entire digital economies on classical AI data center infrastructure will face a painful, expensive transition if they miss the quantum window. There's also a darker side to this story that deserves serious attention, one that has nothing to do with efficiency and everything to do with security. As quantum computers grow more powerful, they pose an existential threat to the encryption standards protecting every piece of data inside every AI data center on Earth. Current encryption, the digital locks protecting bank transactions, government secrets, corporate data, and personal information, relies on mathematical problems that are practically impossible for classical computers to solve in reasonable time. Quantum computers will be able to crack many of these systems with relative ease. This isn't a distant hypothetical. The cybersecurity community already has a name, fault-tolerant. The moment a quantum computer becomes powerful enough to break standard encryption, banks, government, agencies, and major enterprises are now being told quantum-safe protocols will be essential in enterprise data centers by 2030. ISO and other international standards bodies are already developing a quantum computing security framework, ISO IEC 23837, to address this. The data centers being built today will need to be rebuilt, or at minimum, fundamentally retrofitted to survive in a post-quantum security environment. That's another layer of cost, another layer of disruption, another reason the AI data center model as it exists today is running on borrowed time. What makes this story especially fascinating is the disagreement at the very top of the industry about how fast all of this is actually moving. At CES 2025, NVIDIA CEO Jensen Huang famously said practical quantum computers were still 15 to 30 years away from being truly useful, and that classical computing, especially GPU AI systems, would remain dominant for the foreseeable future. His comments immediately sent quantum computing stocks tumbling. But less than a year later, the very companies Huang was dismissing had delivered breakthrough after breakthrough, directly contradicting his timeline. Microsoft's Majorana chip, Google's Quantum Echoes algorithm, IBM's 1000-qubit processor, Quantum's H2 processor, hitting a quantum volume of 33.5 million. These aren't incremental updates, they're category-defining moments. By 2026, even the most skeptical voices in the industry have had to admit the quantum timeline is compressing far faster than conventional wisdom suggested. The 2025 quantum computing market was already projected at $2.5 billion in revenue, with fault-tolerant systems expected from multiple vendors between 2028 and 2030. Here's what this all means in practical terms. The AI data center industry isn't going to collapse overnight. Classical computers aren't disappearing next Tuesday. But the architecture of the future, what computing actually looks like in 2030 and beyond, isn't going to be 10,000 GPU data centers burning more electricity than Japan. It's going to be a hybrid world, quantum processors, handling the most complex optimization and simulation tasks, classical systems, handling data storage, simpler inference workloads, and the vast majority of everyday operations. But the center of gravity is shifting. The companies and governments that understand this shift and start positioning for it now will be the ones who win the next decade. The ones that assume the current AI data center model is permanent and keep pouring capital into it without accounting for the quantum disruption ahead, are making a bet that history may judge very harshly. The data center industry itself is starting to adapt slowly but unmistakably. Major colocation providers and hyperscalers are now adding what industry reports call dedicated quantum zones inside their facilities. Specialized areas built to host quantum coprocessors alongside classical hardware. ODAT's 2025 report projects that by 2032, 5% of Tier-4 data centers globally will host quantum coprocessors for research and enterprise simulation. IBM is already running a quantum computer alongside a classical supercomputer. Microsoft has been pushing a quantum processor specifically designed to fit inside standard server rack footprints. And NVIDIA, the same company whose CEO doubted quantum's timeline, launched a family of open-source AI models called eSing, built specifically to help manage the error correction challenges that have historically plagued quantum hardware. Even the biggest skeptic in the room is quietly hedging his bets. That should tell you everything about which way the wind is blowing. If you're new to this story, there's one more angle worth sitting with before we wrap up. One that affects regular people far more directly than most tech coverage acknowledges. The AI data center industry, in its current form, is being subsidized by ordinary consumers through rising electricity prices, tax incentives, and utility rate hikes, and those consumers are getting very little back. The $1.4 trillion U.S. utilities are planning to spend on grid infrastructure for AI data centers isn't being paid for by Google, Meta, and Microsoft alone. Estimates suggest residential consumers could end up absorbing nearly half of that total, roughly $700 billion, through rate increases passed on by utility companies. Meanwhile, electricity bills for ordinary families have already climbed 40% since 2021. Goldman Sachs has warned that data center-driven electricity demand will push core inflation higher through 2026, 2027, and 2028. Sonia Carley, a professor of energy policy at the University of Pennsylvania, put it plainly: when a single data center campus consumes more power than 100,000 homes, the traditional cost-sharing model breaks down entirely. Ordinary people are footing the bill for a technological revolution, reshaping the economy, and most of them have no idea it's happening. When quantum computing arrives and starts delivering the same or greater AI capability at a fraction of the energy cost, that won't just be a win for tech companies, it'll be genuine relief for power grids, electricity prices, and every household that's been quietly subsidizing the AI boom without ever getting a stock option or even a thank you note. That's the human story underneath the tech story, and it matters. Here's the bottom line. The AI data center boom is real, it's massive, and it's reshaping the global economy, electricity grids, and geopolitical competition in ways most people have barely begun to grasp. But quantum computing isn't some distant threat to this industry. The trillion-dollar question, and given the capital already committed, it genuinely is a trillion-dollar question, isn't whether quantum computing will disrupt AI data centers, it's how fast. Every credible projection puts commercial quantum advantage within the next 3 to 5 years. Every major tech company is investing aggressively in quantum. Every government on Earth with serious technology ambitions has a national quantum strategy, and every data center being built today on classical computing assumptions is either going to evolve or it's going to be left behind. What we're watching right now, in real time, in 2026, is the opening act of the most consequential technology transition since the invention of the internet itself. The companies that see this clearly will adapt and thrive. The ones that dismiss it as hype will end up holding the world's most expensive, obsolete hardware. Quantum didn't kill AI data centers with a single shot. It started something slower, deeper, and ultimately far more total, a disruption so fundamental the industry may not fully grasp what hit it until the transformation is already complete. And when that moment arrives, the people who saw it coming, the ones who understood what was actually happening while everyone else was still arguing about electricity bills, gigawatts, and quarterly earnings, will be the ones holding the future in their hands. Make sure you're one of those people. And if this video helped you see even a piece of the future more clearly, do one simple thing right now: hit the like button and subscribe, because the story we just told you is only going to get bigger from here.